Today's lesson is on graphing linear inequalities. So solutions to inequalities is the set of solutions that solve that inequality. And usually there's a lot of those solutions. And the easiest way to display those solutions is in a graph where we shade all of the solutions to the inequality. Linear inequalities in two variables have the following form. If we have y is greater than mx plus b, then that gives us a dotted line, and then we're going to shade above because y is greater. Each one of these forms is in slope-intercept form, so it's always compared to y. So if y is greater and y is above or below, in this case greater is going to be above, so we're going to shade above. And then here's an example, y is greater than negative 1x plus 2. If you can see here, this is a dotted line. So the boundary is not included. That means that all of this pink shaded region over here is included, but not on the line. Okay, that's what the dotted part means, not on the line. Our next problem is y is less than mx plus b. Y is less than, because we're comparing to y, it's either going to be shaded above or below. Because it's not or equal to, it's strictly less than. That means we cannot be equal to the line, so the line is going to be dotted. And because we're shading y is less than means below, so we're going to be shading below the line here. And then in this case, we have y is less than negative 1x plus 2. Again, we have a dotted line, and this time we're shading below. Sometimes people tend to think, oh, this is the right side and the other side is the left side. When you're comparing to y is either going to be above or below. So if you take any point on the line and then look below it, that's going to be the below side. Or if you're looking for the above side, just pick any point and mark an arrow above it, and it's going to go straight up, which means it's the side, which kind of looks like it's to the right, but is also above. So when you're comparing with y, you're thinking above or below. Our next example is y is greater than or equal to, That means the line is going to be solid, meaning the solutions lie on the line and wherever you're shading, okay? When we have a dotted line, the points on the line don't get to be included. So this means we get to include the solid line because it's greater than or equal to, okay? But because this y is greater or equal to, greater is above, so we're going to shade above. So an example here is y is greater than or equal to 1/2 x minus 3. So because it's the or equal to, that's the solid line. The way I remember that is the line underneath, doesn't that already look like a solid line? I know that that's kind of silly, but that's kind of how I remember it. The line underneath means it's a solid. If there's no line underneath, that means it's dotted or dashed. Okay, so we have y is greater than or equal to 1/2 x minus 3 on our example. Notice it's a solid line and we shaded above. That means every single point in this region and on the line all solve the inequality. So that's kind of cool. All of those values are solutions. And how many solutions are there? There's an infinitely many. I can't write them all down, so therefore I'm going to graph them. Our last example is y is less than or equal to. So or equal to, less than or equal to means I have a solid line. And that means all the points on the line are included, okay? But because this y is less than, that means I'm going to be shading below. And then for this example, I have y is less than or equal to, notice it's a solid line, 1/2 x minus 3, and the shading is below for that problem. Okay, so that means all of the points in the pink and all the points on the line are solutions to that inequality. Next, we're going to go through our steps. First thing we're going to do is solve for y if it isn't already solved for y, and identify the slope, which we often use m for that, and the y-intercept, and we use the letter b for that. Then I want you to graph the line by plotting the y-intercept first. Put that on the y-axis, and then use the slope to get more points. And we can also think about that as rise over run. Next, decide if you want to use a solid line, if it's greater than or equal to, or less than or equal to. But I want you to use a dotted, or some people call it a dashed, dotted, dashed, I don't really care. If you have strictly less than or strictly greater than, meaning there's no line underneath. Okay, so if there is a line underneath, it's solid. If there's no line underneath, it's dotted or dashed. Step 4, shade above if the line is greater than. Like y is greater than or equal to, or y is greater than. Strictly greater than or greater than or equal to. Either way, you're going to be shading above. So we're going to be shading below if the line is less than. Like y is less than or equal to mx plus b, or y is less than mx plus b. Now there's also another way you can do this. You can choose the side you shade by picking a point off of the line, off, okay? And determine if that point solves the inequality. If the point solves the inequality, then shade that side. If the point does not solve the inequality, then shade the opposite side. No need to keep picking around until you find one that works. I don't really care. If one doesn't work on one side, then it has to work on the other side. So that's another way you can do it. And we're going to show you some examples of both. So for our first example here, we have y is less than negative 3x plus 2. Now, this already is in slope-intercept form, so that's awesome. It's really easy to graph. My slope is negative 3 or negative 3 over 1. My y-intercept is 2. So I'm going to go to the y-axis and put a dot at 2. And then I'm going to use my rise over my run to get more points. So I'm going to rise a negative 3. That means down 1, 2, 3. And run a positive 1. That means to the right 1. So down 3, right 1, as many times as I can off my graph. Or I could go up 3 and left 1, and that also is points on the graph. Now one thing I should note is this going to be a solid line or a dotted line? Well, because it's strictly less than, it's going to be dotted or dashed, whatever you like to say. And because we're comparing y is less than, that means below. Remember, when we compare to y, it's either above or below, because y is vertical, right? And in this case, it's going to be dotted and below. So I'm going to go back to my graph, and I'm going to connect this graph with a dotted or dashed line. And then I'm going to shade below. Now sometimes people have a hard time with this. They want to see this as either shade to the right or shade to the left. But because we're comparing to y, we need to shade above or below. Pick any point on your graph and then put an arrow straight up or straight down. In this case, straight down. So that means it's the side that my arrow here is pointing to. So that's this side. But I don't want you to think of this so much as the left side as it's the below side, because we're comparing to y. For our next example, again, it's in slope-intercept form. So we have y is greater than or equal to 2/3 x minus 1. Now, if it wasn't already in that form, I would spend some time getting it in that form, which I will do for you in another problem. But because it's already there, that's great. We have 2/3 as my m, we have -1 as my b. And thinking about the solid or dotted, because it's greater than or equal to, this is definitely a solid line. And because it's greater than, it's going to be above. Greater than y. Greater than y means above the line. So I'm going to go ahead and graph my b, which is at -1. That's my y-intercept. Then I'm going to use my slope, which is my rise over my run. I'm going to rise 2 and run 3. Rise 2 and run 3. I could also rise a -2 and run a -3. So that's down 2 and left 3. That also gets me points. I'm going to connect this with a solid line. And then I've already decided I'm shading above. Now this one's pretty clear to see above, but if you can't, you can always pick any point, draw an arrow up, and then that's the side that you're going to shade, because that's the side that has that is above the line. So that means any point in this whole shaded region is going to, and including the line, right? It goes all the way up to the line. because the line is solid, any one of those points actually does solve it. If you are unsure, we could try one. Pick any point here. So the point I picked was 0, 3. So 0 is my x and 3 is my y. So if I plug that in just to check to see if this worked, I have 3 is greater than or equal to 2/3 times 0 minus 1. Is 3 greater than or equal to, and 2/3 times 0 is 0, and 0 minus 1 is -1. Is this a true statement? Well, yes, it is. That means that's a solution. So how many solutions are there for this inequality? Well, thousands and thousands, an infinite number. I just picked one and showed you that one point in that area actually did work. Okay? So that's another thing that you can do. If you just want to pick a point, find out if it works, then you can shade that side.